Hello guys, welcome to Brainwave Academy. We are still in dimension as a topic. This is another question to solve. Is application of dimension. The speed c of longitudinal wave in a stretched wire is given by the equation c is equal to square root of e over rho, where e is the young modulus for the material of the wire, and rho is the density. Shows that the equation is dimensionally correct. I have solved some questions in how to show the correctness of physical equation before, and these are the application again to solve it. What I want to do is that we have to solve for the left hand side of the equation given and also for the right hand side of the equation given. If they both giving you the same equation, for example, it is L from the left and L from the right, is dimensionally correct. But if the equation is different, it's dimensionally not correct. So now let's get started. Solution. This question, what you need is the equation. This is c, speed of light. Which is c is equals to square root of e all over rho. They will give you all the terms. They will mention it for you. E is what? Young's modulus, and rho is what? Density. So from left hand side, we have c. I'll solve for c. And c is speed. And I told you speed is equals to what? Speed is equals to distance all over time. Speed is equals to distance all over time. My previous video, whether this one is the speed of light, the speed of sound, or any of this speed, they call it speed for you. Which is c is equals to distance. The dimension for distance is L all over dimension for time is capital letter T raised to power 1. Which means we have L t raised to power minus 1 from the left hand side. The dimension for the speed of light is Lt minus 1. Let's try the right hand side. If it is the same with this, we said the equation is dimensionally correct. Now, from right hand side, what we have is square root of e all over rho. And we know that we have square root of e is what? Young modulus. And young modulus is what? The ratio of tensile stress to the ratio of what? To the ratio of tensile stress and strain, which is what? Stress over strain. And you know that stress, we have tensile stress. Young modulus is equals to tensile stress all over tensile strain. And stress, only this tensile stress is equals to force over area. While strain is equals to extension all over load. And let's get it. The extension is written as length, which means the dimension of extension is L, while that of load is also L. It will cancel out, which means that strain is what? Dimensionless. It doesn't have dimension, it doesn't have unit. Now we are dealing with what? We now come back to what? Stress. Which means the dimension for young modulus now, tensile stress is force over area, force all over area. But force is equals to mass times acceleration, and area is what? Length times breadth. Then, what is dimension for mass? Capital letter M. And acceleration is what? Velocity over time. And the dimension for acceleration is what? Lt minus 2. All over length is L, breadth is so M, which is L times L. Which means that young modulus is equals to M Lt minus 2 all over L squared. This is raised to power 1. We now have E is equal to M L, this is the 1 minus 2 raised to power minus 2. Which means that young modulus E is equals to M L raised to power minus 1 raised to power minus 2. We now come back to this. The dimension for young modulus is what? M L raised to power minus 1 t raised to power minus 2 all over density is mass over volume. Density is mass over volume. Is mass over volume. This is length times breadth times height. That is volume. Which means that the square root of E all over rho is equals to square root of M L minus 1 t raised to power minus 2 all over M over L raised to power 3, because the dimension for L is L, dimension Dimension for B is L. Dimension for H is also L. So I'll clean this side so that I can continue from here. So from here I have square root of E over rho is equal to square root of m L raised to the power minus 1 T raised to the power minus 2. Then I will extend the square root. Remember this one is already here. Then this is for volume. This one is for density. That density I will say divided by m all over n raised to the power 3. The square root of E all over rho is equal to square root of m L raised to the power minus 1 T raised to the power minus 2. Then what am I going to do? I will change this division to multiplication times L raised to the power 3 all over n. We now have square root of E over rho is equal to m cancel m. We now have our square root of L. L is common. I'll add the power because multiplication is minus 1 plus 3. Then T raised to the power minus 2. Which is same thing as square root of L minus 1 plus 3, we have 2, T raised to the power minus 2. Remember, square root is same thing as raised to the power minus 1 over 2, which is square root of E over rho is equal to, if you have square root of A, B now, same thing as A raised to the power 1 over 2, then B raised to the power 1 over 2. You share the square root for them, which means that we are going to have N raised to the power 2 times the square root 1 over 2, T minus 2 times 1 over 2. We now have square root of E all over rho is equals to N, 2 divided by 2 we have 1, T, 2 divided by 2 we have minus 1, which means we have L, T minus 1. If you check it with the first one we have, you can see it's the same thing, which means that the question is dimensionally correct. You now come back here, you say that for since you now say since the right hand side, so the left hand side and right hand side of the equation C is equal to square root of E all over rho is LT minus 1, hence is dimensionally correct. It's very easy. This is left hand side, LT minus 1, this is right hand side, LT minus 1. They are dimensionally what? Correct. Thank you and peace out.